Okay, let's look at multiplying fractions. We're going to start with 2/3 times 9/11. Now, when we multiply fractions, the rule is that we just multiply straight across. We multiply the numerator times the numerator and the denominator times the denominator. And we can do that here, and we would get 18 over 33. Now 18 over 33 needs to be reduced because it's not in simplest form. 18 and 33 are both divisible by 3, so you can divide the top and bottom by 3 and you would get 6/11. Now I want to point out to you, let's write that problem again, that you can also do reducing within the problem, and we call that canceling. If you have a number on the bottom of a fraction and a number on the top of the other fraction, you can go ahead and do canceling, which is to look for a number that these are both divisible by. So we have a 3 and a 9 here that are both divisible by 3. So 3 goes into 3 one time, 3 goes into 9 3 times. 2 and 11, there's nothing that they are both divisible by, so we'll leave those alone. And now we'll multiply straight across the top. Numerator times numerator, that would be 6. Denominator times denominator is 11. We get the same answer. Here the reducing just takes place within the problem and our numbers don't get as big, which is nice. Let's try another one. 6/7 times 14/15. Okay, we can look to see if we can do some canceling. As you can see, if we multiply this as it is, our numbers are going to get pretty big. On the top, we would have 84, and on the bottom, we'd have 105. And that is no fun to try to reduce that. So it's much easier to reduce by canceling before you multiply. Here we have a 7 and a 14. Those are both divisible by 7. 7 goes into 7 one time. 7 goes into 14 two times. 6 and 15 also have a common factor of 3. 3 goes into 6 two times. 3 goes into 15 five times. Now, when we multiply our numerator times our numerator, we get 4. Denominator times denominator, we get 5, and our answer is 4/5. No reducing required. All right, what about if we have 5/8 times the whole number 4? Well, anytime we have a whole number, it can be rewritten as a fraction by putting the number over 1. We want to do that so it's clear what number is in the numerator and what number is in the denominator. Then we can do our canceling. We have 4 and 8 that are both divisible by 4. 4 goes into 4 one time. 4 goes into 8 two times. Now when we multiply numerator times numerator, we get 5. Denominator times denominator, we get 2. Our answer is an improper fraction. Now, improper fractions are fine. Usually once you get to Algebra 1 and beyond in college, we use improper fractions all the time. But in elementary school, we encourage students to always change improper fractions to mixed numbers. So we would want to change 5/2 to a mixed number. So 2 goes into 5 two times. That would be 4. So there would be 1 left over. And we put that back over 2. So 5/2 is equal to 2.5. So that would be our final answer on that one. Okay. Let's try one more with a whole number. 6 times 3/8. Okay, again, we're going to put that whole number over 1. Oops. So we have times 3/8. 6 and 8 are both divisible by 2, so let's go ahead and cancel and reduce this a little bit. 2 goes into 6 3 times. 2 goes into 8 4 times. Oh, my numbers are disappearing. 3 times 3 is 9. 1 times 4 is 4. Again, we have an improper fraction. I want to remind you how I showed you how to explain changing this to a mixed number. 9/4 is equivalent to 2 1/4, but if you were trying to explain to your students why, you could show them What is going on here? One, two, three, 4, 5, 6, 7, 8, 9. Okay, that's what 9/4 looks like. And we would talk with our class about how many fourths it takes to make one whole. So 4/4 make a whole. So if we combine 4 of these, that would be one whole. We've got 4 more here. That would be, for Pete's sake, y'all. All right, that would be another whole. So we have 1 plus 1, that's 2. And then we have 1/4 here. So 2 wholes and 1/4. 2 and 1/4 would be our final answer. Okay, now, let's try multiplying two mixed numbers. So 6 1/3 times 2 1/4. When we are trying to multiply mixed numbers, we have to change them to improper fractions. Now, that is a rule in multiplication and division. But again, I repeat, do not change mixed numbers to improper fractions in addition and subtraction, only in multiplication and division. So our first step will be to change these to improper fractions. 6 1/3, we multiply 6 times 3 is 18, plus 1 is 19, so we have 19 over 3. 2 1/4, we do 2 times 4 is 8, plus 1 is 9, and we put that back over 4. Okay, now, can we cancel anything? Can we reduce before we multiply? Yes, 3 and 9. 3 goes into 3 one time, 3 goes into 9 3 times. Then we're going to multiply straight across. 19 times 3 is 57. Y'all, this is making me crazy. And this is a 4, I think. 1 times 4 is 4. Then we'll have to change 57/4 to a mixed number. So we're dividing 4 into 57. Okay, that's going to go it's going to go in 14 times with 1 left over. So 14 times, that's your whole number, with 1 left over. That goes in your numerator and the denominator stays the same. 14 1/4 is our final answer. This is beginning to look like a kindergartner did it. I apologize. I'm not sure what's going on with this board or this pen. Okay. Now, let's do one more. Not like that. Okay, 4 5/6 times 3 3/5. Again, when you have mixed numbers in multiplication, you must change them to improper fractions. So 4 5/6, 4 times 6 is 24, plus 5 is 29, and you put that back over 6. Then 3 3/5, 3 times 5 is 15, plus 3 is 18, and you put that back over 5. Okay, we look at our numbers now and we see if we can cancel. We have 6 and we have 18. Those are both divisible by 6. 6 goes into 6 one time, 6 goes into 18 3 times. 5 and 29, there's nothing that those are both divisible by that will help us. So 29 times 3 is 87. 1 times 5 is 5. That's improper. We need to change it to a mixed number. We're going to have to divide 5 into 87. Goes in 17 times. That's your whole number. How many times it went in. 2 left over. That's your remainder. That goes in as your numerator and your denominator stays the same. So 17 2/5.